I think coming together between IonQ and LightSync is really the Nvidia knowledge moment that's going to allow us to take the quantum computing technology you heard about in the previous sections and enable it to scale and proliferate really at the large scales that are needed to ensure that we're not just leaders today with the performance that we have, but in every era of quantum computing and networking in the future. And with that, I mentioned that all of these technologies come together, quantum computing and networking in the data center. We'll hear about how we're excited about our quantum networking roadmap in the next.
Thank you, Big Ear. Good morning. My name is Jordan Shapiro. I'm the President and General Manager on the Networking Division at IonQ. We are so excited to share a bit of where we are today on the Networking Division and our vision for the future. Start, I'm going to turn it over to my brother before.
Morning, everyone. As for the second, my name is Greg. I've been in the field of quantum sampling for 28 years, and I started my PhD at the University of Geneva in Switzerland, and I co-founded IonQ and Quantique in 2001. Quantique was acquired by IonQ in the first half of this year, and I'm now very proud to bring the solutions, the quantum security solutions that we've been developing with IonQ to the broader market and to make the cyber world a safer place. So, there's almost not a day without a major data breach. Personal information, government covered information is exposed. Of course, there are different attack vectors behind these data breaches, but one thing is certain today: information cannot be secure without cryptography. You all use cryptography many times a day. Connect to website, HTTPS. Cryptography is working in the background to protect the information. It guarantees data confidentiality and integrity. Now, as we see from these breaches, the traditional security is not working. Each move to a new paradigm in security. Things are about to get worse. For decades, the security of our national security systems, of our global economy, has relied on one assumption: the fact that the math that occurs in cryptography is too hard to break. However, with advances in the field of quantum computing, this is now to change. The progress in quantum computing is sufficiently powerful feature of the computer will be able to break the cryptography that is used. And this represents an existential threat to our global economy, to our national security. Try to imagine for a second a world where states do that scope. One-time payments is not possible anymore. Or power grids remote controlled by hackers in foreign countries. It's not exactly clear when this such a powerful quantum computer will be available, but it may be as close as a few years. And it's now the time to plan and implement a major quantum safe migration. It's all the more important that data could be lookable to so-called harvest now different nature type of attack. Hackers would be intercepting encrypted data today, storing it until the quantum computer is available sufficiently powerful to available, and then packaging. One solution to address this threat is to provide participants in selling mathematics. Of course, in mathematics, calculation is faster and faster. But the laws of physics are set in stone. And quantum key distribution is about using the fundamental principle of quantum physics, the fact that the measurement causes a perturbation to protect information on networks. So on this slide, I'm trying to explain the principle of quantum key distribution. Alice is convention in the country, and Alice is cognitive law, and Eve is French neutron. Alice sends information in quantum using a stream of individual-like particles, so-called photons, and she encodes the bit values of these photons. Bob will record photons using single photon detectors, special components, and if Eve in the middle is trying to intercept this stream, she can't do that without needing perturbation. And Alice and Bob can then detect this perturbation. It's also important to understand that we don't use this technology to directly detect information. Because if we did that, we know that we lost information after using it, and that's using one rule. It's that Eclipse sends a key, a sequence of random bits, and then we use this key to encrypt information that's moved. We heard already today that quantum is now. To prove this, we brought a demo. This is the back of the room, and I'm really encourage you to go and see the demo after this session. And this demo will show you two things. First, the fact that classical communication can be hacked without leaving any trace. On this screen, you see two PCs on the left and on the right. One PC sends a stream, video stream to the other PC. And in the middle, we'll show you that if you put an eDropper that taps the optical fiber, this eDropper can connect the video stream without any detection. Now, in the quantum world, things are different. And we're going to scoop now on the monitoring screen of the QPD system. And on this monitoring screen, you see on the top left the measurement of the disturbance of the voltage stream. And so it's slow, it peaks out. Now, when we stop it, it starts to peak out on the communication, but fluctuation will be caused, as you can see now, and then the alarm will be triggered. Alice and Bob, the emitter and the receiver, will be informed of an attack and will be able to react. Of course, with the perturbation, when the interception stops, the system goes back to normal operation. Again, quantum is now, and we're delivering solutions, quantum key distribution solutions. You can see one of our solutions, IonQ rack. This is our fourth generation system, and it has a high technology readiness. It's manufactured in batches, certified facilities, and it's very important. Security is also important to have independent testing and evaluation. And we were able, with this solution, to obtain the world's first security certification from the National Security Research Center in Korea this year. And we're working with several other regions or countries to extend this certification. This solution is used more and more with increasing awareness of the quantum threat. Acceleration is, adoption is always accelerating. And the solution is used by tier 1 banks, telecom operators, and government customers worldwide. The example to secure data center in governments. It's also used in several of the more than 40 quantum networks that are in operation worldwide. For example, in Singapore, Singtel is using it in its quantum safe national quantum safe network to provide quantum security service. In Korea, SK Telecom has used it to secure its 5G backbone against attacks. It's also important to understand that the solution is easy to integrate. IT team is doing a PhD in quantum physics. We will treat this kind of solutions. It's typically deployed as an overlay to a conventional network and it integrates seamlessly with classical telecom equipment vendors such as Nokia, Sierra, or Cisco. I will stop here. I will pass the word to George Shapiro now, but I'd like to remind you one more time to go see the demo application. Thank you very much for your attention.
Thank you, Gregoire. As you've heard from Gregoire and Chris and others today, when IonQ was founded, we had a vision of scaling our compute with modular architecture based on client tasks. What we didn't know at the time, but soon realized, is that customers came to us wanting to purchase not just quantum computers, but also quantum networks. What we thought was at first an anomaly quickly became a threat. It encouraged us to scale our business in quantum networking 2 years ago, and earlier this year to formally launch the quantum networking division. What are we doing in the quantum networking division at IonQ? We deliver commercially ready quantum networks, securing the world's critical infrastructure and setting the groundwork for vast interoperability between quantum devices. We specifically build production-ready networking hardware and software, which allows IonQ to be uniquely situated to transmit quantum information from point A to point B. We're also compatible with existing telecom fiber, so we can embed ourselves into current data centers for AI and otherwise, and link a little bit about the devices that we build in the quantum networking division and produce today. We have the leading technical, manufacturing, and commercial capabilities in the industry here at IonQ, which has allowed us to become the one-stop shop for enterprise-ready quantum networks worldwide. Here's a quick overview of those products. First, we create photon sources. We're creating a core connection that allows one quantum device to interact with another. We also build quantum frequency converters, allowing different types of devices, any type of quantum device, to interact with the same network using commercial fiber. We build quantum detectors to allow us to know when entanglement is happening and to use that to make decisions for applications ranging from computing to networking and communications. With the addition of the new licensing technology, the quantum memories, we're able to build quantum repeaters. This is relevant for networks that are on the ground because you can now extend that network further than you would otherwise be able to. We also provide quantum switches so that our customers can choose which devices they want to interact with on the quantum network. And some of those devices might include quantum computers. We envision a world in which quantum computers can interact with each other, enabling new use cases everywhere from cluster to distributed quantum computers. Moreover, we build and offer timing synchronization devices which are for building quantum networks. We make timing controllers, time factors allowing for precise coordination of different devices that are connected. Last but not least, we offer quantum security endpoints. Today we offer two types of endpoints, prepare and measure, and entanglement-based. Prepare and measure is in production today with leading telco and financial institutions, as Gregor mentioned. Entanglement distribution is also in production today, offering in some ways an even higher level of trust and security because you are able to take the same entangled information and distribute that across multiple cores in your network. Both of these approaches leverage the core principles of quantum mechanics and physics to make data information theoretically secure, meaning that it can't be eavesdropped on without you knowing about it and being able to fix it. So in whole, we are building the full suite of quantum networking products, which is why we're the one-stop shop. That brings all of these devices together to supercharge data centers today and lay the groundwork for quantum data centers of the future. IonQ is building the infrastructure for how all quantum devices work. But our ambitions lie beyond that. While we're pioneering quantum computing on the ground, we have customers coming to us asking to take quantum networking to the next level, space. Our acquisition of Capella gives us components to advance our efforts to take quantum computing to aerial and space-based networks that are truly global. We can leverage technology like the IonQ Solteris platform to build quantum secure networks at ground stations. Solteris also allows us to combine quantum key distribution, or QKD, with post-quantum cryptography, or PQC, both of which we offer here at IonQ. We like to say PQC everywhere, QKD where it matters the most. Soon, our quantum offering will be available for communications across coasts, borders, and oceans, thanks to our space demo. Beyond the pure communication use case, we are looking at distributing entanglement globally, and will also launch space products there. We envision entanglement being generated and distributed across data centers across the globe to connect a variety of quantum devices, be those computers, quantum communication endpoints, sensors, timing devices, you name it, all globally. And importantly, the quantum networking division is breaking boundaries every single day with our customers. Today, I have the honor of sharing two customer announcements that we've been able to produce with the Air Force Research Lab in the US. First is that today we've been able to show that in a single quantum computer, we can generate two zones for qubits. One that is a computing zone where you're running compressed gates, and the second is a networking zone, and we can shuttle qubits from one zone to the other. That computing zone allows us, like I said, to run complex algorithms. The networking zone allows us to take that information and extended into another quantum computer. Core to what we're trying to do in the next room division. The second announcement for the Air Force Research Lab is that we've achieved a major milestone to connect our quantum telecom wavelengths to classical telecom fiber. So we've been able to demonstrate frequency conversion from 493 nanometers, which is a wavelength for FM, into telecom. This is a major accomplishment. It allows us to put quantum computers onto the network and allows IonQ to take the first two steps. Impressively, we're also seeing all this technology using it in production today. Customers can go work with EPB and Chattanooga, the electric power board there, and use today an IonQ-powered commercial quantum payment distribution network. So today, customers can get onto this platform and use our technology live for payment distribution. World first. Meanwhile, in South Korea, SK Telecom, as Redgar mentioned, is securing the nation's data through quantum key distribution. So this is sensitive AI and customer data, securing their 5G traffic with IonQ. The important takeaways from today on the quantum networking division are as follows. Quantum networks are here, already here. They're securing the world's most sensitive data. IonQ is building the foundation for the world's connected data in the future. Thank you very much.
I'm going to take a moment for some Q&A, so just to repeat, everyone has a QR code in front of you, or you can pose any questions for our presenters. So I'm going to start with a question for you, Dean, which is, we presented today that we'll get to 2 million qubits in 2030, and IBM hasn't been announced getting to 2 billion. What gives you the confidence that we can outperform IBM?
It's a good question. So if you look at our roadmap, right, 256 next year, 10,000 the year after, 20,000 the year after, 200 to 2 million, right? The basis for those numbers is not just spending, right? If you think about the integration work that we have in front of us, this is a collaboration with Bahir and the licensing team in terms of what does it take to start integrating a collection of quantum networks into our systems. Look at the technical kind of bits we need to go through. Likewise, if you look at the technology for astronauts, you saw the unit cells. You saw that we need to scale the strategy that relies on replicating that unit cell. And this goes from a current 1D architecture to a 2D architecture. So the size of the unit cells, the ability to grow the unit cells, the ability to tile those relies on a progressive set of technology maturation, increases in die size. So at the end of the day, we've built our current technical roadmap based off of very sound technical reasoning and scheduling that is honestly completely doable and based in kind of sound engineering judgment and like we don't need miracles to happen. As Chris pointed out, we are relying on all of the semiconductor manufacturing and processing industry to reuse the existing technology we're already doing for that kind of unit cell replication. So from an overall perspective, 2 million at the end of the day is exactly on target and exactly just a natural scale of current capabilities that exist in the market.
And then maybe for you, Chris, what will Oxford Ionics leverage from IonQ's facilities to build a 256 chip?
Well, I think what's valuable, right? We need our clients to exactly the same units the number of items as I does. And actually, when you look at the materials we use our system, we look at the assembly requirements for this, they're 95% the same. So this means we can essentially directly put these two things together. The teams will already have staff attempts. And we just get the correct speed up by doing that. We don't have to retool significantly on this. We essentially deliberately put these electronic integrated qubit control chips into the same kind of systems we already have. and then it's just an integration challenge.
How about the fact that since we're increasing qubit capability so quickly, at what level will volume production actually be targeted? Sorry about that.
That's a great question. Ultimately, what we're doing is hitting having to drive our important parts. What we can do is rely on things like the standards that about the supply chain, where we already have volume drivers that are other people have already paid to solve the pain, and we can just use their learnings. And I can't say enough just how much the semiconductor supply chain is like magic. There's trillions of dollars of investment gone into solving miserably hard problems, which we don't have to solve as other people. So, for example, the semiconductor processes we use have been developed and matured for decades. We're not having to do anything new there. We're having to do the finance, but the application of those is probably massive advantage of scale.
Awesome. Maybe we'll turn to the networking side a little bit. We have a question that asks, could you please discuss how your quantum Internet products could differentiation aside from the fee structure?
Yes, so the quantum internet is a network that allows distributing antenna node across a network. If you distribute antenna node, you are able to have strong correlation between photons. You can measure these photons. You locally get a random number, but it will be the same random number at the other end of the network. And random numbers are a very important resource in cryptography because they are used for keys. And so by using the quantum internet, you can establish keys between locations, sequence of randomness, and then use these keys to encrypt quantum communication. That really is a two-step process. Quantum communication first, and then encryption using keys.
Awesome. Another question from you to take that. To what extent is the software vision more middleware versus an application layer centric idea, and how will we monetize it by system sales or discretely?
Say the question one more time.
To what extent is the software vision more middleware versus application layer centric, and how will we monetize it? System sales or discretely?
So we've had to invest in a software stack, literally the full stack. It's not just the middleware that we've been invested in today. We talked about the need for qubit control at a very low level. That has been a software investment since day one. Right? The capabilities that we have in terms of our qubit control differentiate us definitely in the market. As you move up the stack and start getting into our OS and the capabilities that it has, if you go even beyond the OS in terms of what we need to do in terms of job schedule, all of those are differentiators for us in terms of what we can do with our systems, computers. And then as you go even further up the stack, you'll hear from Arnold Bronside a little bit later today. And we have investments in our application work, right? We're building out libraries for chemistry. We're building out other capabilities. In the overall, I think, our side chat section, you'll hear Martin Arnold runs our solutions team. The team is working with customers, understanding their needs, taking that learning and reinvesting in the capabilities that can be deployed to other customers. So from an overall software perspective, we are trying to build an ecosystem. We're using customers now, they're getting familiar with the development environments, they're getting familiar with our capabilities, and just we expect overall customer lock-in over time. The ability to take customers, get them familiar with being able to start running small applications or larger applications. We've seen this with our work with Hyundai and others in terms of their ability to take early work, leverage that, pass it on to other technical teams within the company, and then continue to drive and move forward.
Awesome. I'm going to take it back over to your side of the ribbon, Gregoire. A question about why use the quantum internet to connect to quantum computers across the world? What value does that provide beyond building two racks right next to each other? And on a related note, how does IonQ quantum computing fit into the satellite internet?
It's a great question, and thanks for the question, Kevin. There are many reasons that you conceivably want to connect quantum computers at a distance. And today, the first and foremost reason is just availability. Quantum computers are new, they're coming out at the capability levels of products. And so being able to reach across the border and in a trustworthy manner use someone else's phone these days. But in the future, we envision that there might be local reasons that you want to have a quantum computer, for example, next to a local quantum sensor. And so the lower latency of that sensor and computer being next to each other, let's say in the UK, allows them to interact more quickly, allows them to process data and then send it over to a quantum computer in the US. So there are many different reasons. The other thing I should mention is an application called blind quantum computing, or QT. This is an application where you take a quantum algorithm and run it in an abstracted, hidden way on someone else's system, that you don't necessarily need to trust the algorithm system. It's a super secure methodology. It's of interest to governments and enterprises worldwide that we're already working on. And it's another good reason why you might want to use someone's system across the world and run a secure algorithm, but know that no one's going to see what the work is that you're doing.
Thank you for that. Could you also expand a little bit on entanglement distribution that we have deployed and the work we're doing there?
Yes, so I mentioned one example of commercial entanglement distribution network that we have at EPE in Chattanooga, Tennessee. And so today customers can go online on that platform and start working with entanglement from one local data center to another in Chattanooga and demonstrate secure communications, demonstrate different use cases on PKE, but also experiment with new use cases on the enterprise side. So everything from instantaneous transmission of data to parallel processing across multiple systems. We've also announced that we're looking at quantum computer to be in Chattanooga, so that will be the first site to have a commercial quantum computer and entanglement distribution quantum network co-located. You can envision that there are many opportunities there at the intersection of computing and networking once you have entanglement distribution online.
Thank you. With that, I think we will take it back to the main agenda for the day.
My name is Ariel Mosting. I use product application for the computing side of IonQ. And there we go. And I would like to start today's presentation by acknowledging how confusing quantum computing industry can be from people the outside. Companies like ourselves are throwing a lot of acronyms at you and technical specs, and companies are talking about accomplishments and breakthroughs. And it's just confusing to those talking about how all of these things add up eventually to actual value to us. And value in quantum computing, outside of this, comes from the expression of value to customers. And today I want to try and fix that. So the interesting thing about applications of quantum computing is that every little choice affects application. Every component, every architectural choice, every layer in software that my colleague Dean was talking about in his presentation, they all affect eventually the outcome of these applications, will make them viable or not viable. And all of these outcomes come down to four groups of things that you can categorize. One of them is what we call time to solution. How long does it take for an application to make a solution? Next one is the accuracy of the solution. There is the cost solution, or the energy consumed being getting into a solution. And usually it's very small, right? And to help you understand how IonQ's roadmap impacts these outcomes, we selected four algorithms. These are randomized algorithms. These are milestones in quantum computing. These are main algorithms in escalating sort of level of complexity and demand. And what we're going to do is talk to you about how these algorithms will be enabled by IonQ's technology roadmap, and how does it compare to the known roadmaps of our competitors, to give you a scale of actual outcomes of our chips. Initially still on. So I will high technology, enabling a more accurate result that consumes less energy, yet the results faster in costs. But let's look at some specifics. So the first algorithm that I would like to take through here is a top, it's an AI called Moonboard. So this algorithm, again, I'm used with forming faster and consume less energy end to end. And in this case, it's 14 times faster than the closest competitor that we already reject. Next one is ESG detection. This is for satellite imagery, so we have intelligence insurance industry. In this case, scientific technology enables 20 times less energy, and it still costs less, energy consumption is lower, more accurate, and so on. Third, portfolio rebalancing in financial services. Again, IT technology 170 times less energy consumed. And last, in this instance, Shor's algorithm, which you might have heard the name, so they measure and stake in quantum computing, the ultimate evidence that quantum computing delivers on the vision that it was always conceived. In this case, we predict in the next few years, our stake 2048, and that's used for secure web transactions, and the ECC 256 used for cryptocurrency like Bitcoin and Ethereum, they will become possible. And our technology for this type of work already, so again, it will be faster, it will be cheaper, and 2.5 times lower cost. It is worth noting that you see the X's, the red X's, not every system out there will even be able to run these applications, simply based on their stated roadmaps, their common roadmaps. But we still went through the exercise of evaluating, given the benefit of the doubt, what if they could get the how will it perform? We can see here, simply, even if they get there, the disadvantage because they started from is very significant. Because we simply build better foundation, which is everything you heard here and from people on the beginning. So let's talk about this foundation and let's talk about how to compare across these foundations. So the industry and IonQ started from the beginning of the early stages, spent the last decade building this foundation that we're talking about today. So how do you compare between these foundations across companies? How do you know that our projections for the future are actually going to be? Well, the best way is to look at some benchmarks. So let's look at some benchmarks. The first benchmark, and this is actually running today against the top line of our competitors. So the first one is an algorithm called QAOA. It's a very powerful optimization algorithm that we ran with our partners like Airbus and the Oak Ridge Analysis. As you can see here in this graph, the top line is IonQ. IonQ 4 is outperforming IBM's latest system, 34.7% higher quality solution. And what's interesting in this example is that the more you give the system, the bigger that becomes. Next benchmark. The next one is it's called QFT. It's a workhorse of quantum computing. It's already one of the most useful tools in signal processing. And as you can see here, again, the top line is 1 times IonQ. IonQ Forte is able to produce here 181% higher quality solution. Oh, I apologize. This is 73. I'm bringing the next one inadvertently. 73% higher than IBM and superconductor. The next one I really led with a conclusion. This is a very interesting, very powerful algorithm, search algorithm called FAA. And in this case, you can see that the amount of dots that you see there are samples of the search performing on random numbers. And horizontal lines are the average score of the benchmark. And you can see here, this is not even IonQ 40, this is older generations. We ran it with IonQ Aria, and Aria is outperforming all other, the top of the top option of the competition with 181% higher quality solution. So all these advantages eventually comes down to opportunities. As Bill pointed out in his opening, we have to be there first. We turn on our systems. We've been running with customers. We've been testing these algorithms. We establish a foundation that is simply more robust. Therefore, we get opportunities ahead of everybody else. And the opportunities are urging everybody. You can see here examples in in pharmaceutical, healthcare, logistics, service industries, engineering, financial services, security, manufacturing. These opportunities are popping everywhere. It's up to us to capture them and convert them into actual business, which we are actively pursuing right now. It's all eventually about finding key algorithms, running them on powerful systems that are tuned for these algorithms because of the choices that we're making every day, and using them to find the right use cases that address real business needs. So let's look at one example that we recently did. So this is a partnership between AWS, IonQ, first and foremost, AWS, Nvidia, and AstraZeneca. In this example, we chose to address a step in the drug discovery process. It's a way of scaling up the yield of drug production by using special purpose catalysts. And the way we did that is use quantum processing to accelerate a classical simulation process. It's a quite elaborate process to get at that's the level to get into extract data. Work very closely with these partners, and the result of it is a 20 times improvement of end-to-end time to solution in this. And as Nicolo said in the beginning, if you actually follow the QR code and look at the publication, the claims are actually much greater. The improvement in the steps that we are actually accelerating is more than 600 times faster. But the end-to-end, we want to be conservative, so we're showing the 20x improvement there. But basically, I encourage you to get a publication on that. That's a clear evidence of advantage like that. The next example is very interesting. It's a new approach to allow for improving the performance and the cost of large AI models. Things like LLM are not limited just to LLM. So what it allows customers to do is take their existing large model that they invested sometimes $1 billion just to train a large model, add the quantum layer to it, and use the quantum layer to retrain or the AI model to perform highly specialized tasks with very little additional training and very little data. It excels at situations where the available data is very limited. And you want to get high accuracy despite the fact that you did not have a lot of data and you did not have to train this model with a lot of data. And as you can see here in the graph at the bottom, our energy measurements demonstrate that IonQ consume energy linearly as the data model increases, while GPU increases exponentially. So it's also a way to reduce the energy demand in AI. Going back to the same 4 ideas where we excel, we're making it cheaper, we consume less energy, we make it more accurate, right? And we make it less expensive. So let's watch a little video about this unique new approach before proceeding to customer updates by Rima and Margaret.
Quantum fine-tuning is IonQ's hybrid approach that makes large language models, or LLMs, smarter, more energy efficient, and less resource intensive. By adding a quantum layer to any foundational AI model, we can unlock measurable accuracy using fewer training cycles and less energy. Today's LLMs, like GPT, are powerful, but they're generalists. Out of the box, they work well on broad tasks, but struggle with specialized high-stakes accuracy, like detecting subtle fraud, classifying rare medical cases, or parsing nuanced human language. Prompt engineering alone won't bridge that gap. You wouldn't run your most critical workflows on the same tools a student uses to write an essay. So why rely on an untuned model when accuracy is everything? The fine-tuning process retrains models for domain specificity, but the classical approaches to fine-tuning are slow, expensive, and energy-intensive. Moreover, they often plateau with noisy, limited, or complex data. This is where quantum classical fine-tuning comes in. Rather than just improving a base LLM, quantum essentially customizes or repurposes the model for a specific business-critical task. By adding a quantum layer that captures richer, higher dimensional patterns, we augment classical AI to unlock capabilities that were previously out of reach. The result? Higher accuracy with scarce data, fewer training cycles, lower energy consumption, less resource intensive. In sentiment analysis, simple cases are easy for both systems, but when there is nuanced human expression, like short or mixed tone examples, classical models often misfire, while quantum gets it right. Across our tests, quantum delivered over 70% win rate over classical in nuanced cases, exactly where accuracy matters most. Overall, we saw a greater than 3% accuracy lift, cutting total errors by 8%. At enterprise scale, using AI models like DCR1 don't just run a single step, but tens of thousands of iterative inference steps before surfacing an answer. So every 1% of accuracy compounds. A 97% accurate foundation model maintains signal across depth, while a 94% model erodes into unusable results. The difference isn't trivial. It defines whether an enterprise can deploy these systems in business-critical scenarios. IonQ's quantum fine-tuning model can enable high accuracy even at enterprise scale. And the smaller training footprint means faster cycles and lower energy costs. The future of fine-tuning isn't just smaller, it's smarter. And it's here today with IonQ.
Hello, everyone. I'm Rima Ahmadian, Chief Revenue Officer at IonQ. Thank you for being here today. So quantum is no longer a future promise. It is a present reality. Our customers realize that quantum computing and quantum networking will shape the future. So they are acting now. We have two types of buyers, mission-driven and ROI-driven customers. The mission-driven customers are investing because they are interested in fueling economic growth, attracting world talent, and driving innovation. These are the universities, the countries, the states, the cities that are building quantum hubs and ecosystems to be leaders in the quantum economy. This category also includes governments. As we all know, governments are investing heavily because they know there's a quantum race out there, and the nation that masters quantum first will get to define the global order. Then the second category are the ROI-driven customers. These customers are investing for a totally different reason. They are investing to solve their hardest problems. Problems they're not all able to solve today with current technologies. They care about accelerating growth, solving the competition, and defining industries. These are pharmaceutical companies creating new drugs, manufacturers building new materials, financial services customers building new cutting-edge models, and also enterprises in general that are looking to protect their data from intruders. That's where they use quantum security. So our customers know that they need to invest now to be able to shape the future. And we're proud to help them lead the way. So with that, I'm going to turn it over to my colleague, Margaret Arakawa, who will share with you examples of our success and our momentum. Good afternoon, everyone. Again, my name is Margaret Arakawa. I'm the Chief Marketing Officer for IonQ. Prior to joining IonQ, I had the privilege and joy of working at Microsoft for 20 years, in the old days, and the new days, and the mid days. So I want to step back just real quick to give you kind of a timeline on how and why we feel so confident. So I picked the 1970s as a starting point for compute. And because I left work at Microsoft, we cared about this one thing. Remember the PC on every desktop? The PC on every desktop that became servers in every data center. But in the 70s, it all started because PCs were being developed. And we're all of a sudden getting freed from the tyranny of a VAX machine, which I probably found, or a mainframe. So now you get a computer, as you all do, on your desktop or in your homes. So that started distributed computing and distributed computers. That then led to something else. And what that was the internet. I was overjoyed when the internet launched in the 90s. But it actually launched in 1983, so to speak, when there was this protocol called TCP/IP that allowed people to communicate over the internet, or when the World Wide Web was actually delivered as a way to actually communicate. So the internet built on the fact that we had computers on the desktops. Because the internet now had a protocol, at the very beginning of the internet, as we all might know if you were around, it was neither fast nor secure. But it got there. It got to the point where Netflix now can actually leverage that incredible speed, and I can have 1 gigabyte downloads at home. What then did you get with the internet besides this distribution of these computers and ability to connect and transact? What followed was the cloud. I don't know really when the cloud was born, but I put 2002. The reason I put 2002 is why. What company launched a service that is the largest cloud service in the world? AWS. 2002 was AWS and SolarWorld. And I decided that's when the cloud started because they leveraged what? Amazon.com to build, and they are now running the world's largest cloud service. Could you have done that without the internet? And could you have done it without distributed computing? And the next phase is AI. Guess why I picked that date? 2022. It's really odd, terrible times to pick, because actually AI was officially discussed in the Dartmouth conference in 1953. But I picked 2022 because that was the ChatGPT moment for people to understand how to be productive as a person. And then they understood now, how do you get productivity out of the cloud, out of the internet, and out of AI? So here's a bunch of companies that have been around: Microsoft, AWS, Nvidia, Google, and Oracle, which had a great week earlier this week. The reason I put those down is all of them invested in this journey. They all had to create the infrastructure, but all of them are actually cloud providers. They are working with Nvidia, they're working with each other. Oracle's cloud actually runs on everybody else's cloud. So do we. Because the way I've learned, at least I learned, and on my continued journey, because I was an intern at Intel, you have to invest in the infrastructure, and you have to have a benefit for customers. The benefits for customers for IonQ today, what you can buy or what you can look at right there, we provide the basic things that customers want. They want to make sure that you are high performing. And Dean actually talked about, we are on path. We will be delivering the world's most powerful quantum computers. And you require that in compute. You need to prove that you have high performance. When you're networking, you need to actually care that you are doing it at lower cost, that you're doing it with scale. Chris Fallon's talked about the lowest cost per qubit in the industry. Jordan talked about incredible scalability. Mahir talked about it from a photonic perspective. But when you think about scalability, think about all that infrastructure and all that investment you have to put in. And then Gregoire also talked about world-class security. I spent 3 years at Microsoft running a security group. I was told that I had to help Bill Gates prep for his last RSA security conference. I actually thought I was going to get fired because I was like, I don't know if I can prep Bill Gates. He's like, brilliant. They said, no, you have to tell him everything Microsoft does and sells in security and get him ready to get on stage. And the thing I learned is you got to work really, really, really hard. You have to keep at it. You have to have the IP, and you have people that want to make sure that their security is world class. So with that, I will say that those companies did what we're doing. We have world class 6th generation hardware that we're selling. We sell it with an application layer that allows companies like Nvidia to partner with us. When you see Nvidia and you see quantum, they only can partner with people who have a software layer, hybrid services that allow a classical computer to talk to a quantum computer, because it's a symbiotic relationship. That's why Nvidia loves working with us and why we're able to work on incredible applications together. And finally, as you heard, this is the stack that we sell. We sell end-to-end, one-stop shop quantum networking, a type of quantum that is applied to networking in a way that, for the first time, You're going to have this belief and knowledge that your network is the strongest, most secure network capable in the world today. So these are the customers that have bought what we are selling. Incredible customers. World-class Fortune 500, Global 1000 customers like Hyundai, like T-Mobile, like Samsung, like Cisco. We also have, as Rima has talked about, we also have incredible ecosystem partners, and it matters. We have to scale our partnerships. The last job I had at Microsoft, I was running Windows in the United States. Small little business, that if I got a cold, Microsoft would be ill. So I made sure that we did well selling Windows. When I first got to Windows, I was running Windows 8, and all our customers were mad at us. And they should have been mad at us, because we delivered a product to them that was a surprise. The UI had changed, and we didn't get feedback all along the way like we had traditionally done. By the time we launched Windows 10, we were excited, and what I focused my entire job at Windows and Microsoft was scaling via partners. Ecosystems are built with partners. If you don't have, we're the only ones that are actively working with Google, Amazon, and Microsoft, and all our quantum computers. If you have a little credit card right now, you could go start today. You could learn how to code on quantum, because we have to democratize it. And finally, we have obviously our incredible government, national labs, universities. Silicon Valley started because of what? Because they had incredible smart people at all of these schools that were local to a lot of innovators and entrepreneurs, and that's how they became Silicon Valley. We are trying to create quantum innovation hubs all around the world, and we're partnering with universities and government labs and the government to make sure that people don't wait for quantum, because quantum is now. So I'm going to take you on a really quick tour of the last year. The last year for IonQ was a tremendous year. What I wanted to just highlight in 1 year alone, who were these customers, partners, and universities, and what was the news that we actually delivered? Oops, sorry, there we go. The first one is the University of Maryland. We signed a $9 million partnership with them to help them continue to build their quantum capabilities. And again, we have to democratize quantum, and we have to make sure that students learn quantum. If they're working on a CS degree, they should also look at whether or not they should learn how to code for quantum. One of our largest deals, one of the largest in the United States of America last year, in September 2024, was the United States Air Force Research Lab. It was a $4.5 million contract. This is an incredible contract, and in fact, we've actually added to that contract, and are now over $100 million in our government contracts. Nvidia, like I said, we worked on a new chemistry application. We did it with IonQ, which is their next platform for co-working, collaborating with the quantum companies. But you must look at quantum companies that invest in that. That's the only way we're going to scale. In December, we shipped a quantum computer to Europe. A lot of quantum companies have quantum computers in their labs. So that's something that most people don't realize. Amazon, Microsoft, and Google, they all have quantum computers. They're not commercially available. So they put our quantum computer on their clouds, because we need to be commercially available, because quantum is now. We also have landed as part of an anchor partner to the state of Maryland. You'll notice, search state investment in the United States, country investment in quantum. You'll see that the state of Maryland put a big stake in the ground to say they are building $1 billion capital of quantum. And they chose us for their anchor partner. We're showcasing quantum applications with ANSYS. Who's ANSYS? ANSYS, which was just recently bought by Synopsys. They're one of the largest companies on earth that work with high-performance computing companies that need high-performance computing, and they do computer-aided engineering or computer-aided design. So you need to work with the companies and the partners that have the most complex problems. AWS, as I said, great partners with them. They were excited when we announced global availability of our latest and greatest quantum computer for the enterprise at an remarkable AQ36. DARPA, I know that there's questions about what DARPA means and who they are. Obviously, they are pretty much the inventors of the internet. They are investing because they know quantum is now. And they'd like to get the leaders in quantum to help them standardize and figure out the future of quantum. We were selected as one of the partners that are going to help DARPA and the government do that. In April, again, we landed a $22 million partnership with an electric power company, the EPB company that's in Chattanooga. They, who have always been incredibly world-class in leading, they actually have the first gig fiber to all of their citizens. They are now the first utility in the United States to have a quantum computer and a quantum network, both developed by IonQ. We in April were lucky to be selected as somebody that the Japanese National Institute for Industrial Science. And it matters, right? Because where is the most high performance computing and compute in the world? It's in the US. And there's other foreign entities that we shall not name. But the largest ones that we allied nations, the US, the UK, Germany, France, Japan, Korea, all of those places. Japan selected us because they want to advance quantum and AI in Japan. Sweden, there's this incredible company, Nvidia. I don't know if you've heard of them, but they actually were creating autonomous vehicles that were electric. So they took two tracks and put it together, and these interesting looking trucks are actually autonomous and electric. And they're working with us because logistics and optimization is very difficult. We also partnered with AstraZeneca. That was something that Niccolo talked about. Why did we partner with a pharmaceutical company? Because they have brilliant scientists that know how to discover and accelerate drugs using classical, and they partner with us because quantum will be able to discover and accelerate the next drugs that could cure cancer. That's what we all want. We want the cure for cancer. The longest development time is actually in testing and drug development. We have to accelerate that, and we're working with AstraZeneca to do so. In July, we partnered with KISTI, the Korean National Quantum Center of Excellence. Very excited, we are their primary partner for them to develop their quantum center in Korea. And then finally, our R&D breakthrough that we just announced. You've heard of De Beers, the diamond company. Turns out they also sell diamonds, synthetic diamonds, or materials that can be used to accelerate quantum computers. We here talked about photonic interconnects and talked about all of the things he's doing to make sure that the speed between quantum computers and chips is actually fast. Diamond materials is the next generation that's going to help that. So I did want to leave you with quantum is now. All of those companies have invested in quantum with us, and we're partnering because it's the time. Like I said, in that evolution, we didn't just appear. I've been doing this I've been in compute for 30 years. It's time now to invest in quantum and partner with those companies. So with that, I will let my next esteemed speaker come up. He's the Chief Operating Officer of IonQ, Inder Singh. Welcome.
It's hard to top that, so thank you for having me. It's great to be here with all of you. I get the easier part because you get to move forward with the statements from me today. But I do want to make sure that you appreciate what you heard, my lens. Right? I joined IonQ as the board director and a leading member. And I came in the logistics with Citadel Farm. Some of you may have heard of it's a semiconductor design company in the UK. I was helping it get ready for an IPO. They wanted to use it to sell to Nvidia and then back to IPO again. Exciting journey. To me, it was sort of like the present and past of computing, and maybe, I'm not going to demonstrate, maybe the future as well. So classical computing is on a track. You heard all of the Jensen launch statements, heard of the GPU successes, that much to that. But if you think about kind of how these things are coming together over time, we find the next something space. You're actually going to smaller and smaller and smaller nodes. You still want to be followed like semiconductors, and I'm guessing some of you do. You don't have to pay. If you look about at 5 nanometers, going to 3 nanometers, 18 angstroms going to 14 angstroms, they're heading down the path where quantum mechanics is. And quantum computing follows a different set of laws of logic, wave theory versus particle theory, and leverages immense more, exponentially more power if you can start to manipulate things at that level. And I remember when the company approached me to join the board, she wanted to CFO and sold to ARM. And when I did join on the board, I asked our CEO at that time, I'm taking it from sport, I think quantum is the future. And we'll name the individual, he's not right now, so it's not a minute. When he said to me, like, it'll never happen. It'll never happen. He did it right. He had been doing it for 27 years. Right? At that time, most quantum companies that I was looking at, compare IonQ to, had like no revenue, there are R&D shops, pre-revenue companies wanting to go public. This was one of them. And when I looked at what this one had, and I looked at the leadership team, and I looked at the capitalization of the company, I looked at the comfort that this one had the funding, over $500 million in cash to invest, then okay, you increase the chances of success. You have to have the right scientists and engineers and researchers and marketing people and everything else. And what they've delivered is, you'll see on the next graph, is kind of that growth. That's the revenue performance of the company. 2021, when the revenues were 1.6 million, that's when I joined. And when I looked at the roadmap that I was there for grow, Nicola was on the board, he had been involved heavily in the company. I got comfort that we had the money to invest, and now the question was, can we actually build? These revenues are by selling machines. I haven't seen another company in quantum have this kind of trajectory. I'm not trying to brag on this, but these are the facts. Also, they're not forward-looking on it, so I'm not saying, pass this for a while. But our goal is to make sure we do the things on the right-hand side of the page moving forward, which is grow our customer adoption. And you've seen, I think, lots of names, examples of how that's happening. Why is that happening? Partly because of the reasons that Ariel talked about, the kinds of applications that might be coming, the things around drug discovery, just things around battery chemistry, how can I make an EV go longer? There are problems that are intractable problems that classical computing might solve one day, but takes years and years. And a machine like this, which can, instead of doing serial processing of information, can do simultaneous processing of all the different possible scenarios and tell it what to look at. And I'm not saying it's the panacea. I'm also not saying you should think of this like, if quantum wins, GPU loses. No. I think we end up in a hybrid world where both coexist. There are certain workloads, like large-scale matrix multiplication, when you're doing LLM training, that's what that is. A table of weights and a table of data, and you're slashing them together and multiplying them many times to get the right answer. Wow. Maybe quantum's not exactly the best at that, but you saw an example of what we can use quantum for. Take that and make it better. So if you think about the intersection of Venn diagram of AI and quantum, and that crossover point is where you can really turbocharge models. I'm not predicting that will happen. I'm not saying that that's not what we're investing for. So the first business there is important for you to understand. I think you saw a number of speakers present. I've listened to them. So this is, I think, day 5 on the job for me as CMO and CFO from the board into the company. But I did not want to miss this journey. I didn't have to do this. I was on a number of boards. People called up and said, hey, you become sounding board, et cetera, et cetera. You want to join that? You want to do segment? Didn't say that. And so how can you say that? How can you say no when this technology can enable the betterment of humanity? I've always worked on this topic with my entire life. But this is one of those where if we deliver, if we scale to the qubits you saw, if Chris Balance executes on getting us to 2 million qubits, 2 million qubits, and he does it using a semiconductor ecosystem with the plan, that means it's going to be the lowest cost solution. The semiconductor industry has been around for 4 decades, 40 years plus. The existing infrastructure, the boundaries exist, you don't believe. You also don't have to put in lots and lots of lasers to hold these ions. Use RF lasers. So it becomes smaller, cheaper. The other materials things you saw already will go on that. And also, I want to make sure that you understand, this is not easy. Quantum is the mixture of science, research, engineering, productization, sale, deployment. And in the first few days, what I asked the team was, if you have now been able to create a 64-qubit machine, and you can scale it, and then you can go to 2 million eventually, what are the things that will hold you back? And the answer I got was not what I thought I would get, which was like, well, we need to do more research, we don't have to. No, it was just, we need more people. We need more people to do finance. You can sell more if you finance. So I said, how many people? I'll tell you how many people they wanted. He said, something like that. And so the head of manufacturing reports to me as supply chain, and then Dean, we saw presenting, that's full hiring. And this is a no regress. So we have the ability to now start turbocharging things. Again, not a forward-looking comment on guidance. But my hope is that we continue this trajectory. I think our opportunity is if we continue this trajectory to deliver. You can talk to a lot of companies. I have tons of respect for IBM. My first job offer out of engineering at Columbia was at East Fishkill, New York, with IBM in 7th. I didn't vote. I didn't take that job. I have immense respect for the brand and that icon. I will never put a company down. And God bless them. We have D-Wave, we have other companies that are in this industry, which is a nascent industry. It only becomes a real industry when a number of companies win. So every time I say like a breakthrough from Microsoft, great. Breakthrough from Google, great. It's validating the fact that this works. Customers see those. We build a machine. Keep outpacing it competitors, frankly. We have about a 2-year lead, in my view, at least, on actually commercializing the product and delivering it when I do something. And I think that the ones who are 2 years behind will try to catch up. By then, it will be another 2 years forward and forward. You'll see that we have the resources to do that. And Niccolo and I got to work on depository is basically talking about leveraging the semiconductor supply chain. We have the lowest cost of build. I'm not saying we're going to sell it at the lowest prices, but we can build it for a 20th of the cost of anything else. Like our cost is measured in millions of dollars, and you saw the slide earlier. The other costs were measured in billions of dollars. So we still need to do a lot of development more, and to do that, we need to have a balance sheet that supports it. So again, Niccolo and I and the board and the team decided we needed to ensure we had enough cash on hand so that issue. And earlier this year, we made sure that we raised enough to get us to about almost $1.7 billion of cash. If we need more, we will raise more. The interest in the space is there. The proof points of delivery we have shown. People have deployed our machines in Switzerland. Germany's interested. There are countries in the Middle East that are calling Niccolo. I speak Arabic, so you can go there. These are things that didn't happen. So AI is still very hot, will remain hot. I hope it does. But the intersection of AI and quantum, but also quantum alone, is incredible. I was showing sort of like a hot, sort of topic slide later on. But when I look at kind of what we have that no one has, no one in quantum has the computing, the networking, and the security. And people always think about security and they say, well, we need it. People think about security in current terms. I worked at Cisco Systems for corporate finance. We had a security business, it was great. We thought it was terrific. There's Palo Alto, the private trade, you can name them all. None of them work. None of them work. Right? I mean, I've been at companies. You layer on firewall, VPNs, no matter what you do, intrusion detection, endpoint protection, it's not working anymore. People are finding their way around it. The bad guys are getting in. Nation states in particular are getting in. So then what do? You wait for quantum to happen and then put in quantum security? It's too late. They've already taken your data, which is encrypted by RSA 2046, which is the highest level of RSA encryption. There are different flavors. This much is like far less than 2038. So you can start working your way up and decrypting if an adversary actually gets their handle on a quantum machine. Working on it. Our goal is to be the first country and the first company in this country to achieve that. I'd rather not have an adversary get there first. I'd rather have us get there first. We think we can. And so people think about quantum security and they say, well, I'll put it in my You need it now. Encrypted with quantum, you heard Gregoire. Gregoire wrote the research paper that started this company 2 decades ago, right? And he has now, he's too humble. He won't tell you that there are 2 companies in the world that are doing this that we now own, thank you, and Toshiba. And I'm not saying this is a law, it's a full established. But in that space, you have a unique ability to secure networks today. So as a management team, we talk about this and say, what do we focus on? That's what I'm focused on. This is opportunity for us now, while we wait for qubits to grow and to compute. And then the fact that we have Capella allows us to take that same quantum security from terrestrial networks up to a satellite, and then down again. There are programs we're working on, the US government is working on, others are working on that want us to sort of build a stability now that is resilient from jamming. You've heard of GPS spoofing. Satellites can be interfered with. Quantum secure satellites, not so much, very hard. So this hardening, the Chinese are actually 10 years ahead in some areas. You know that, and I'm not telling you this state secret. Search it. And so they launched MyCS, which was a satellite, the first one in 2016, and then they just, nothing wrong with it. I'm not aiming at China. I'm saying our infrastructure has to also withstand the onslaught of jamming, interference, all of those things in the same time frame as anyone else. And I think we have space to make up on, time to make up on, and now the assets to actually develop those products, demonstrate them, deploy them. The fact that we are global, partly through our acquisitions, partly because our customers have pulled us there, gives us locations where you see all of the world here and growing. The demand is, I think, more than how much we can actually manufacture in our factory today. We have a factory in Seattle. We're looking at expanding our ability to put more into that factory for building. You know, the product has moved from the Bunsen burner and beaker stage to the let's try something stage to the making it stage. So, I joined because I was like, wow, okay, I don't want to be part of this. It is turning out to be true. I hope other quantum computing companies win also. I have no objection to having like other players in there. But I've seen you're working in many industries, AT&T, Cisco, others all the time, you always sort of end up with 2 or 3 leaders. And 3 to 5 years from now, I'm thinking you must switch that. You'll see the leaders emerge. And then the others will sort of become niche players with one product. We don't intend to do that. The one-stop shop that you heard earlier, we're not trying to become a supermarket for everything. We're trying to be the place to go. If you want to secure your network, if you want to actually make sure that your communications are encrypted today so that if an adversary builds it either tomorrow, they cannot decrypt it in the future. They can decrypt all the other communications that are all the same. I'm not trying to scare you, but I am saying to be scared. You know, blockchain was mentioned, I think maybe Jordan mentioned it. We all know what blockchain is. It's the currency, a stable coin. At the root of it is blockchain. The value of blockchain is, any crypto investors in here? I never actually had the courage to buy cryptocurrency. You don't have to think very much. But that is a similar technology that depends on primary manufacturing, it's elliptical versus, normal sort of primary manufacturing, etc. The blockchain itself is valuable because it has a history of every single transaction that Bitcoin, right? You can see who bought this when, all that transaction record exists, so you can see if something legitimate or not. Because it has all that history, it's very difficult to quantum secure. Quantum in 3 days. So I don't know that people wrap their heads around it and make my head more prepared. If I try to, I'm not going to. All I'm saying is go on the cusp of that. I'm not the only one saying that. On this sort of top list, the Department of War has said that. And I'm surprised to have seen that they've admitted this within 3 years. I think this is nothing possible than that. Any company that puts wood behind that muscle has the talent that we have in this room and beyond, the founder of the company, Robertson here, ran the NRO office, has blue badge access to every top security agency country, access to the Five Eyes, access to the NATO countries, and help us show them what we can bring them. You have Rick Muller, Rick ran, DARPA, Rick ran IRPA. DARPA is for defense, IRPA is for the intelligence community. He was in that position, and we hired him on for that position, which I've never seen. Marco, are you in the room? There he is. Marco ran the quantum and all other R&D efforts, really focused on quantum, for a very large bank. Can I name your bank? Thank you. I didn't name it. And when I listen to the conferences and I listen to Jamie when I attend some of them, he's proud of the tens of thousands of engineers he has in that bank. And they're investing in these types of things. Turns out they're a customer of Renoir on IonQ. So they're putting in sort of the QKD solutions, which is what you protect your crown jewels with. This cannot be hacked. You use QKD. You use a lesser version called QKC, which has an encryption approach, unlike the entanglement approach and others. And look, both are good. One is gold standard, the other is platinum standard. You decide how you want to deploy it. But when commercial institutions realize they need to protect themselves now, they start doing it. So yeah, not trying. We were today here was we basically now secure approval for the OI acquisition that we announced. That is huge. That happened this morning. That was a government-to-government process between the United States and the United Kingdom, jointly deciding. I wasn't there, so I wasn't in their head, so this is my interpretation. But I did the ARM deal with Nvidia, so I know kind of how they think of it. National priority for both countries, they think they're better together than apart. and they've allowed us, a US company, to buy that asset. And Chris Valens and his team are on board. They understand the semiconductor cycle. They use an existing fab in Europe today. My team looks at supply chain and the resiliency and things like that, so we'll take advantage of the synergies over time. But right now, I want to invest and keep investing in this space. You can see the other thing behind that. The building and deploying the quantum applications today, I wanted to make sure that you all have. And that is huge. So not only are we kind of like building the machine to work, we're making sure that we can show the applications that are on. And you may only see like a small peek into it. I have the longer list from Ariel, where are you? The longest list from Ariel, who is trying to do all of it, and I'm saying, prioritize what you can get to now versus later, versus later, versus later. And the next fireside chat that you'll see is with Marco and Martin joined us from Microsoft, and led a lot of their quantum efforts. What's my message? All those people are under our roof now. This is how you de-risk the strategy. This is how you know you can spend 1.7 billion. And we have now with Niccolo and the seed taken the approach that we're going to acquire what we need to acquire. If we can build it, we'll build it. If that takes too long, we'll accelerate by acquiring. And we will take a very measured approach. We put in place an integration team. If you have questions around that, etc., we can address. I ran a Cisco's M&A program, and we did one a long time. We're doing here. But it's like a machine, and we're trying to make a small machine. We want to make sure that these all have synergies to them, and that the fact that we can deliver an impactful thing for our existing and sort of future customers. So interest is huge, product is here, team is here, we have a plan. That's why it's important, right? But I'm not sure this. I didn't do this. I want to do this. So with that, I'm going to actually stop so that we can have either Q&A and a fireside chat come in. But I'm thrilled to be here. You know, the CFO role, yes, I got 1.7 million to spend. So I'm you know, just going to try to do the capital allocation part of it. You can do that. If you need to, we'll raise it more. Capital sources to go. And then our job is to make sure that we prioritize the things that matter most. And if cryptography can be broken in 3 years, has to be another. If drug discovery can be accelerated, it has to be another path. And you know, the applications are enormous. Each of them takes effort. The other thing that I think was alluded to or mentioned, I think I'm going to get into it here because I'm no time. The other thing I think that was mentioned was there are a number of applications that can be done that have incredible future potential, but not immediate partial value. On the finance side, we're going to balance those two things. So if we can build applications that we can monetize now on machines we're building, take that customer, upgrade them to our next generation machine, we can do even more applications, so on. That's how we discuss the, okay. Cool. I'm going to go off stage and let the next one over. You'll have questions, like I'll be part of hopefully sitting around here. But also afterwards, if you want to follow up, let's do it. I do have the CFO hat. Many of you are in the financial industry. Some of you I've worked with, many very welcome. Many people I've known, many I haven't. I want to get to know you better as well. And yeah, I hope you get as excited about this as we are. If you don't understand quantum mechanics, I get it. It's hard. Einstein called it spooky science. He couldn't understand it. You're a good company. I'm on the world John Mayer. They published a book called Quantum for Dummies. I'm not going to sell it. But like, I bought it. It has pictures in it. It doesn't have the calculus. And you start to understand that, oh wow, entanglement is real. Superposition is real. Schrödinger's cat can be dead and alive at the same time. I don't care how good it can. And what Gregar said is important, which is the security aspect is with this, the minute that somebody tries to hack into your network, they disturb that, and somebody, asked a question, which I think was handled well, that, okay, what do you do then? When you read about traffic, those of you who have followed telecom and Cisco networking and so on realize that there's a concept called self-healing networks. So if the network is quantum secure, the nodes decide where to send it if this hacked. So I hope we get us the industry to that level, but this is a level of security that has never existed before. I thought it would take a while, but it could.
We have a lot of questions, so we're here not to sit on the seats, but to answer your questions. There is going to be a fireside chat right after the talk. Let's have Nicola, if you want to come here, so that all of us are here and having us some questions that you guys have been kindly asking us. We appreciate that. And a reminder to make questions in the Q&A to our host. So the first question, just so they can talk. All right. We're okay, we don't need the other two. Thank you. Excellent. Let's go, Hannah. Appreciate it. Question's name is for you, which is what are the reasons you hear from customers for why they're investing in quantum now instead of later?
Yeah, so let me divide it into two parts, quantum networking and quantum computing. So with quantum networking, you just heard the Q-day is near. Q-day is when quantum computers will be able to break RSA 2048, which is what the internet runs on. So that day is near, so that's why customers are investing now to protect their data. Now, let me move to quantum computing. Quantum computing, there are a number of reasons customers are investing now. One, as you heard this morning, you can't simulate applications that run on quantum computers anymore. Our 100-qubit machine cannot be simulated. So to run those applications, you have to run them on our quantum computer. That's one reason. Another reason is customers have to figure out what problem they can solve on a quantum computer. As we know from the days of when GPUs were introduced, you have to know what you run on a CPU, what you run on a GPU, and then what you run on a GPU. Once you understand your workflow and understand what you run on each one of those processors, that's how you can really improve your workflow. So customers are investing now to build a workflow that's optimized and ready to really accelerate their problems and solve the hardest problems. So that's the second reason. Third is we've shown value today. We don't start value today that can improve their business, and they all know that we're going very soon to broad advantage and then superiority. So now is the time to invest. You can get value today from hybrid applications.
Maybe taking it into the future for Margaret, how do you envision the longer term quantum application TAM, and how do you view the split between augmenting versus replacing classical computing approaches? We have a quick analogy for you. If you go to your kitchen and you have a stove, an oven, and you have a toaster, and this magical thing came into your kitchen, it's called a microwave. Most people have no idea how microwaves work. There's a magnet, it excites molecules, and something that's cold becomes incredibly hot. But a microwave right now doesn't solve all of my cooking problems. I don't use it for toast, but I use it for very quick, very powerful meters. So quantum computing and classical computing are always going to be symbiotic. The TAM for quantum computing is every data center in the world. Every complex problem in the world that cannot be solved today
like weather, like price encryption, like pharmaceutical speed. None of those can be solved now. So the TAM is every data center in the world and every complex problem that is not being solved today with supercomputers.
Awesome. Well, when I think about maybe for you, Nicola, our customers and our TAM, what's stopping us from actually selling access to technology giants like Microsoft and Google through an IP segment or something like that, since you're so far ahead in the R&D side?
Yeah, so I get questions like that frequently, as well as, will we get acquired as the other related one by a hyperscaler? Our job at IonQ is to run the company as well as we can, and make both of those sorts of conversations, honestly, as expensive as possible. We are focused on being an independent company for forever, and we obviously see ourselves as having a fantastic future. When people like Inder Singh join us, formerly the CFO of ARM, people like Paul Baser join us, formerly the General Counsel of EMC, these are individuals that I obviously enjoy working with and are betting that we are the next $100 billion market cap company, if not next $1 trillion market cap company. We're also students of history, honestly, and you've heard a lot about our investments in software so far today. We are very clear of the value in the full stack, and we want to make sure that we preserve our ability to capture that value all the way up the stack. So we're careful is the long and short of it. There's a price for everything, as they say, but right now we believe we're leading the pack, not just in the hardware layer, the compiler layer, but also into the application layer as well.
Building on that application layer, Ariel, we've talked about Nvidia today in a few different contexts, but a big question about, could you expand on our partnership with Nvidia and the work we're doing?
Sure. So Nvidia is a critical player. Remember that everything in quantum is happening. Quantum doesn't exist in isolation outside of this. So a leader in AI and a leader in computing is clearly a partner of ours. Look at AstraZeneca collaboration, right? It's actually a good model for the kind of partnership we have. IonQ brings the quantum, the hardware, and the algorithm. AWS brings the infrastructure, the classical infrastructure, the data center, and the knowledge around how to do high-performance computing. AstraZeneca brings the knowledge from Cisco. Nvidia brings the connecting tissue, so we have this closed connection that allows for orchestration of complex computation across high-performance computing and quantum. So each player brings something to the table, and together value is created. So we work very closely with them on multiple projects, and we are a key player in giving them feedback on how to make their infrastructure even more powerful.
Thank you. So then I think we'd like to invite our Q&A panelists to the stage. If we can take a seat, and thank you very much.
He's right behind us.
We foreshadowed this conversation, I think, for most of the day, and our star-studded cast is here. We're going to talk a little bit about why such fantastic talent as at IonQ has chosen to be here, as well as the synergy between our various product families. Each of our fireside chat participants are well known throughout this industry and have set records for themselves in IP creation. I think my colleague here, Marco, holds as many patents that he's co-authored as most companies do. And Martin Rogler is well known for being the towering figure in quantum applications worldwide. Rick Muller, you've heard Minter and I gave up a seated directorship at ARPA to join us. And ARPA, of course, has recently been announced as the chairman of the newly created IonQ Federal. So I'm going to start with you, Robert, if that's okay. Robert has had a distinguished career in government. He has served in multiple administrations. He was the director of the National Geospatial Intelligence Agency. Just to show us all what that looks like, I'd love you to chat about the connection between the Oval Office and IonQ. I'm going to show a slide here of all the presidents, vice presidents you briefed, and of course, directors of other intelligence agencies that were your colleagues.
Well, thanks. Well, and by the way, I'm glad you pointed out the patents and the world records that everyone else holds. My record is, I think, well, there's no way to prove or disprove it, so you're going to have to take my word for it. Over 400 ovals, meaning 400 mornings with President, most of that with President Obama. I also served for 3 years under President Trump's first term. And what I learned through that experience is you're about as good as your last 5 minutes and perhaps 5 seconds in some cases, because you can imagine no more momentous of a person to try to inform their next decision, right? To create some sort of advantage. And for me, Nick Lowe, as we've well laid out here today, I know of no pursuit as momentous, as consequential as pursuit of quantum, and more than the pursuit of it, the application of it. And so for me, it was an easy call. Even though I'm not going to contribute to the science component of our company, I feel confident that I can take the experience on the stream and contribute to those partnerships, to those mutually beneficial relationships that we're going to need to leverage the science firms. It's an honor, personally and professionally.
Wonderful, Rick.
I'm Rick Muller. I've been at IonQ for 2 months now. Before that, as people have mentioned, I was the director of IARPA. IARPA is many are familiar with DARPA. IARPA is the Intelligence Advanced Research Projects Activity, which is a version of DARPA that is intended to serve the intelligence community. So it was stood up after 9/11 to have the same type of high risk, high payoff research that DARPA delivers for the DoD to the intelligence. IARPA was one of the kind of foundational funders of quantum information science in the United States. They had a number of programs that funded Kristen Monroe and Jung-Sang Kim's early research in these areas. Well, I guess it's not necessarily research, but a lot of the work that later went into IonQ was funded at one point by IARPA. And that history in quantum was, part of my excitement about going there. Before that, I was at Sandia National Laboratories. I helped build a quantum information science program there. Sandia was one of the first national laboratories that realized the combination between quantum information science and national security and a large cleared workforce was something beneficial. And we were fairly early in that space. And Sandia also has a connection to IonQ. Sandia was one of the pioneers of the surface ion trap. That's the foundation for all of IonQ's technology. I was thrilled to come to IonQ. I think, throughout my career, it's been quantum information science that's been the most fun for me to work on. It's just a great field intellectually and as well as culturally. And so when I left government, I wanted to kind of pursue what I think is a unique opportunity to the scaling quantum information science. And IonQ had the right team in place, it had the right technology, and it had the right vision and leadership, I think,
to be the main player in that.
Transitioning from the fully political, fully technical, and Rick is a unique addition to the team, which I'm honored and proud of, as I am with everyone on the stage. Rick, is a modest man, but he has, at the front row seat, I think it's safe to say, with everything that's going on in this country, from a quantum hardware perspective, certainly the last 26 years. And you don't want me sharing this, Rick, you told me after you joined that when you thought about whether you might want to be in the commercial sector, there was only one company that you applied to. And that to me speaks volumes and volumes and volumes, given the vantage point that Rick is coming from. As a scientist with a political connection, if you will. So thank you, Rick, for being here. Marco, tell us about your vantage point.
Thank you. First of all, I'm really honored to be here and to be a member of the IonQ company. So my career is not so diversified because I only work for 3 companies. 24 years at Nvidia Research here in York Heights, New York. 5.5 years at JP Morgan Chase, and now 2 months at IonQ. So at Nvidia, I was the global head of the markets and applications, and the next chapter of my career was to go to JP Morgan, where I was the global head of applied research, quantum computing, and quantum key distribution. Now I'm at IonQ, where I'm senior vice president of industry relations. So Nicola mentioned my patents, so that has been part of my career as a researcher. I have 647 patents, and with my team at JP Morgan, we wrote, and also with my team at Nvidia, we wrote a lot of papers, scientific papers as well, in Nature, Science, and so on. So I am really excited to be at IonQ because it's time for me to, I experienced working for a quantum provider, IBM, and a quantum user, JP Morgan. I really wanted to go back into working for a quantum company, where quantum is really an mission. And IonQ was my first choice because at JP Morgan, I had for the first time in my career the ability to be on top of the entire quantum ecosystem and monitor everything that was happening, meet with all the quantum companies and all the quantum key distribution companies. And IonQ was almost at the top. And we were so excited to see the latest developments that we will discuss today. At JP Morgan, we saw the acquisition of Antique, which was our choice to work with since 2022. The investment in quantum networks and quantum security, which was another thing on which JP Morgan was really, is really very strong and very determined. So JP Morgan doesn't use just PQC, post-quantum cryptography, but also QKD to have security in that. So the most natural choice for me was to work for IonQ because it's time now to commercialize quantum computing. It's the new wave of this technology, commercialization, and I wanted to be part of it here at IonQ.
Thank you. Well, Martin's actually a relative veteran on the stage, and he and his team have actually been delivering the quantum advantage that we've been reporting on this year. So we're honored to have you here, Martin. He's got the IonQ socks, so he's been here longer than a few of us, but please tell us how you see your journey.
Thank you, Nicola. So I'm the for quantum solutions. You heard about our work in Ariel's presentation, so work with customers like AstraZeneca and others. My own background, my first technical work in quantum computing goes back to the mid-90s. I did my PhD in quantum computing. I came in IonQ coming from Microsoft, where I worked for about 11 years. I've been here for 18 months. Before that, I worked on actually going back to DARPA. I was leading a performance team together with Raytheon and a few academics in an early version of the quantum resource estimation effort about a decade ago. Before that, I worked for NC, a Japanese electronics company, also quantum. So I guess you could say I've seen all kinds of sausage and all sausages in the United States.
Quantum sausage, quantum sausage.
And what excites me about IonQ really, couple of things, like first of all, the qubits, what about the qubits, what's unique about IonQ, why that is definitely was a big factor. There's more though, so we got a battle-tested team, like the applications team has been working with customers for many years. There are many challenges you go through, right? You deliver value, and you also have to debunk a lot of things and educate the customers. So there's a lot of learning. This big factor that's amazing, and to also have the cultural values that behind that. And the third thing is from Dean Gassman in the morning about our engineering roadmap. It's a big factor to make systems and not to make test beds for science experiments. There's a big factor, a big difference between the science experiment and actual machine. Like you come to IonQ, that the systems are amazing. But just behind this tool is like we have access to these very advanced systems. We can test our applications, but we also get always access to the latest version. So you heard about the AQ system. This roadmap, down prototypes. My team last week had like hours after that we had access to that system. We could play with it and do experiments. So that's just amazing. Reasons why I'm
Wonderful. So I guess I have one additional question, which I hope everyone will answer thoroughly. I'm going to start on this side. We'll go down and finish on Robert. One of the things that makes us unique as a business is not only that we're leading on the computing revolution and the quantum networking revolution, and we can do this both terrestrially and up in the heavens. But we're the only business that can actually stitch these pieces together in the world. We're the only publicly traded quantum networking company. We're certainly the only publicly traded quantum all product families business. And so I'd love you to chat about how you see those synergies, because they're wide ranging. It's not only long-term scalability and computing, but it's the quantum internet. And I think each of you has a really fascinating vantage point on how this connects.
Yeah. So you heard from Chris Monroe, Chris Ballard, both Chris's and here, what this kind of unique confluence of ideas that allow us to make larger and larger systems. So networking components and also the unique electronic qubit control. So from the applications design or from that vantage point, what's really important, and I'm going to get on my little soapbox for a minute if I can. So we really care about the scale, but we do not want to do just fully applications that run to like 20 qubits and then that's it. Right? We really care about velocity. And so if you're around me, I'm preaching that people will get tired. But there is this funnel of things that go from just an algorithm and a mathematical idea, and you have like 50, 100 of them every day, frequent servers, many new ideas. You go from there and you go to actual applications which have use skills that already narrows down the funnel tremendously. But then there's a step that goes from there to things people actually want, practitioners actually want. They usually already have a solution in place for something, right? Otherwise, why would they care? So we tend to call it a workflow, something much more complex than just like an algorithm, something having multiple moving pieces. So those things might have a huge cluster component, and they need a quantum computer at scale. So the technology you heard about that allows us to scale in fault-tolerant regime to 80,000 logical qubits. So this technology we will use to make workflows and deliver practical advantage, and eventually put these workflows into production. That's what we decided to do about.
Wonderful.
Before I really like what Martin said, I would like to expand on that, talk about the effects of the networking to security. So IonQ is not just a quantum computing company anymore. It's a company that covers all the quantum technology spectrum, quantum computing, but also quantum networking and quantum security. And the reason why we have quantum security as part of our portfolio of products is because, as you guys have 100% heard also from previous talks today, quantum computers already have the ability to break cryptography. I mean, even a few more qubits, and then unfortunately, this moment for the Q-day moment in which a quantum computer can be used to take anybody's public key and compute the corresponding private key, allowing an attacker to decrypt data and impersonate users. So we need to have a solution that is no longer vulnerable to quantum computing attacks. And it's not, the foundation of this new solution should not just be mathematical assumptions. So right now, for example, the cryptographic methods that I use rely on the assumption that an attacker doesn't have enough computational power to break cryptography. And this assumption lasted many decades, but is no longer valid now with quantum computing, because we know that with a quantum computer, an attacker will be able to break cryptography in minutes. With a classical computer, it would have taken trillions of years, and with a quantum computer, minutes. So IonQ is the only company in the world that has the entire spectrum of quantum security, because we support both prepare and measure QKD and entangle QKD. So QKD has been criticized in the past because they say that the distance between the two endpoints is between 175 kilometers. This limitation is completely surpassed with the light-seek technology. We're going to have quantum repeaters, and with Commercializing technology, we're going to have connections using satellites, and we can be able to have connections to QKD across continents. This is not something that unfortunately China is already doing that, so it's a good thing to know that somebody has already been able to do it, but we have to do it also in the United States. And the reason why I would say just one more thing, the reason why we need QKD, it is because it's the only technology that is mathematically proven to be unbreakable. So in order for the attacker to break the exchange implemented by QKD, the attacker will have to break the laws of physics. So it's impossible. And the other very desirable property of QKD is that it is the only technology that allows you to immediately detect the presence of an eavesdropper. No other technology for cryptography has this benefit. So, and JP Morgan Chase, as I mentioned, I convinced the company, even Jamie Dimon, spoke with Jamie Dimon with the entire building committee many times. I said, we cannot rely on classical cryptography anymore. We need to have QKD and we use the IP technology. I think I may be wrong, but I believe that JP Morgan will be the largest customer of Cryptographic. And now Cryptographic is IonQ. So it's very exciting to be here and to leverage this entire portfolio of quantum technologies together.
Thank you, Marco. So we're moving to the top secret security clearance bit of the panel. We have a growing number of fantastic contributors that have secret security clearances. Joseph McNaughton is also in the audience for anyone who wants to carry lunch and fits into that bucket. But Rick, please transition us from the fully technical to the technical political, if you will.
Yeah, so the two of the best conversations I had while I was at DARPA were with people who are in the room now. It was with Chris Balance and Mihir Bhaskar. And it was obvious to me in those conversations that the technologies they had developed, and this was, I don't even know if they were, well, they were almost certainly talking to IonQ at the time. I had no idea they were talking to IonQ at the time. But it was just obvious to me that both of those technologies took a massive step forward towards making what was Chris Monroe, who was also in the room's original vision to modularize quantum computing. And this brought us much closer to having, national security relevant quantum computation capabilities. It was always obvious you were going to have to modularize and network quantum technologies together to really get an appreciable amount of computation. And these were really exciting. I mean, first, they were both incredibly exciting people. I mean, you don't talk to either one of them long before you realize that they're really remarkable thinkers. But also, it just moved quantum computation that much further down the road.
And, in the past, we used to say vaguely, well, it's probably going to come out in 10 years. But we were kind of vague about the steps required. And really, very recently, and I think the IonQ roadmap reflects this, we're now seeing, Q-Day on the horizon, and we start to understand the technical steps that are required to get us there. And that's incredibly exciting, a little bit scary, but it was certainly something I wanted to be a part of. And, the reason I say that, in addition to the team and the technology, I was excited by IonQ's vision is that I didn't have to tell anyone that those two technologies were critical to the future. IonQ figured it out. By the time I started talking to them, I think they had announced the LightSync acquisition. But I was hinting broadly in some of my interviews about these electronically controlled gates, and boy, they sure look great. And, how are you going to get all those lasers together for 2 million qubits? And little did I know that they were already deep into talks with that technology. So it was just, it was a remarkable convergence of the technology, the people, and I think really pressing national security issues that I is well addressed or well posed to us.
Thank you, Rick. All right, our second former agency director, I think Robert's agency has something like 15 times the number of employees that IonQ has. So we appreciate the scale and the talent that is our firm, and Robert's, I'll ask you to take us home.
Thanks, Nicola. When I mentioned I also testified more than 100 times in front of Congress, and the most important skill I learned there is this is intended. Great question. Thank you for the question, and then answer the question you'd like to answer. I'm more serious now. I'm old enough to get involved in what's called the midpoint of our space race in Global. Since the 1980s, and we needed to win that race. We as a country, we as an industry, and by the way, there was an industry, it was government owned and operated, it was classified at the top secret level, but we couldn't have done it as a government without our industry partners. And we won that race. We won that Cold War. We're in a race today. We're in this room, we're providing, we're in public, company, we're sharing with you our plans, the race, and I agree with Ender. I'm thrilled with the ecosystem on this room. That's awesome. Involved in winning this race, many of our partners are here today. But unlike the Olympics, where if you come in second in the race, they give you a silver medal, no silver per second here. We must win this race, and that we, yes, as IonQ, I'm here for a reason to help win that race. But we as a country, we as economy, it's the way of life, not to win this race. It's that critical, it's that consequential. So, lesson for me, I have a life of service. I feel this role here is just a continuation of that service to a mission above self. Yes, we're a company. Yes, we want to impress you with our earnings and our growth, which we are confident we will. But what really generates my passion here is that focus on winning that race for the country, for our way of life. And so, very, very proud to be part of it. Thank you on this stage.
Thank you for joining us, Robert. Thank you all for staying with me. And I'm going to move on to close our session here. So I feel it's important to be a disciplined business when you're a public company, and we're gonna finish exactly on time today, which I feel is a real feat. I want to thank our team for organizing past morning. I'm going to tell you a little bit about why I'm so excited to be here, why I'm so excited about where we're going. As you've heard from Robert, this is not just about national as a fear of also national economic security. There is no aspect of applied science that we don't positively impact. This is an amazing company. Our employees love being able to work in the morning. Our whole team does, because no matter what your thing is, whether it's pharmaceuticals, through the logistics, through cryptography, defense, through material science, through sustainability, you make a bigger impact here than you will or can anywhere else. We are absolutely in it to win it, as I think you've seen this morning. We have shown this year that we will absolutely spend money to make sure that happens and to move things to the left on our roadmap, because time is everything. It's not time, we're actually not that worried about competitors. As you've heard, a 5-year lead is an astonishing one. Steve Jobs, 07 launched this thing called the iPhone. Some of you in the room might have it. And he said at the time, I think I have a 2-year lead over Nokia and RIM. And the 2-year lead converted into a $4 trillion market cap difference, right? I think we have a 5-year lead, and we're going to continue to press our advantage by investing appropriately. The reason the lead matters, as I said, is not about commercial competitors, it's about nation states. And nation states are, of course, ferocious competitors. IonQ is tightening our security protocols, if you will, because what we're doing impacts so very much. You've seen today also that the very best talent in the world wants to be here. Right? We're only applied by IonQ. That tells you a lot of what we've seen the last 26 years, looking at the government's quantum programs and what they've invested in, as well as how they've interfaced with other companies. You've seen that A-pluses want to work with A-pluses. So Carson Rhodes, Chris Balances, Mahir Bhaskars, and many, many more. We have our applications team, Martin, Marco, Rick, etc. And there's a whole other layer or two below that who don't necessarily report to me directly, as they say, but are equally vital in continuing to prevail and advance our lead. Everyone wants to be here because everyone knows that 1 + 1 = 3. Right? We have all of the world record holders of this company for fidelity. Right? Chris Monroe used to hold that record until, ironically, the other Chris at our firm stole away from him. We also have all the world record holders for, I never get the exact phrase right, but basically quantum networking transmission speed. I was held over here at Oscar, so guess what? Chris Monroe stole away from him his lab too. How amazing is that? Right? We have all the world record holders at our firm. And that gives us a darn good chance of holding all the world records for the next 5 years, the next 10 years. Success begets success in every industry that has this amount of applied science, means fundamental science, means great engineering, means commercialization. And you've seen today how extensive our lead is, not only in quantum computing, but how extensive it is in quantum networking. And you heard from Inder and Jordan and Gregoire and Marco about the criticality of quantum key distribution for our nation and for our corpus. Everything I'm saying today applies to the Five Eyes, to NATO, and all allies. At the end of the day, the cybersecurity market is truly enormous. It's enormous today. Everybody needs QKD today. It may not be the only thing we need, but it's definitely one of the things that everybody needs. When I think about who wins computing revolution, I said at the start of the day that it's all about miniaturization, unit economics, and mass market penetration. This is the only firm on the quantum computing, if you will, revolution that is actually leading on all of those vectors. The most logical qubits, the lowest cost for fully fault-tolerant machine, unbelievably low cost for logical qubit. If you look at some of the data we shared today and divide numbers by a number of the logical qubits we have, you come to 2 orders of magnitude at least as a lead. I'm this matters, right? Because as we've seen in every revolution, the more people that use things, the more that gets built on top of it, right? Collaboration matters. Chris Valens and I will be in the UK together next week, just as we have been here together, because what the US and UK do together matters a lot, and what the Five Eyes do together matters a lot. And setting IonQ with Conference Licensing, our friends at Capella, has the opportunity to drive advancements in collaboration, cooperation between nations and between agencies as a dramatic accelerant as well as differentiation. The talent we've assembled is not only about the hardware, the compiler, cybersecurity, or the computing, but also the application layer. And I said at the start today that I think quantum machine learning, quantum AI is probably going to drive, even more upside than we have demonstrated on our application roadmap. But I think over the next 5 years, IonQ is positioned to continue to win, continue to advance our lead and accelerate it. I think it is very likely that we're going to look back on 2025, in 2035, the way we look back on 2015 for the days of that in 20. And we're going to say, how crazy was it that we thought that nuclear reactors that are powering data centers the size of football fields is the future. The future is going to be power saving, cost saving, and strong AI models that are perfect quantum computers. By the way, the regulators like to, right? Because quantum computing, despite being about superposition, actually is pretty deterministic, but we know what the algorithms that run actually do. So the EU is going to like that, US is like that. I think we're going to move into a quantum world. Yes, I agree. CPUs and GPUs are still our phone. GPUs, CPUs, and GPUs will grow the total compute market together. But there's no doubt that every time you move more powerful machines, the majority of that capture goes toward the leader in that sector. This is an industry that will have the same network effects of everything else in the tech sector. Right? There will not be 45 companies in the CPU space, the GPU space, the QPU space that succeed. There will be one big one, there will be a second place, and there might be some people fighting over the last 5% of the market share. Right? We absolutely believe we're going to be the umbrella of the business of quantum. That's quantum computing, quantum networking, quantum sensing, quantum and space, how this connects together. We're the only company that can do it all, can win it all, and stitch it all together. And with that, I would thank you so much for your attention this morning. We look forward to having lunch with everyone and allowing you to attempt to ask us the questions that would be a Reg FD violation if we answered them. Other than that, thank you so much for your time. I really appreciate it, and I look forward to working with them. Thank you for your support, and thank you for your trust.
It really does the future start. At what point do ideas become reality?